Hello everyone, welcome to my channel. So in this video, I will show you a step-by-step guidance on how to run stable diffusion model on your AMD GPU in Windows. So don't worry, I will provide a detailed step-by-step instructions. So if you are not familiar with Python, I think that's okay. You can always pause my video to check my command and to do it yourself. So, one thing I want to mention is that my hardware is AMD GPU 6700X. So I think majority of the most recent generation of the AMD GPU will be working. Depends on what I read. So I highly recommend that you give it a try. It's a really cool machine learning model that you can try on your AMD model right away. So feel free to let me know how it goes. So the first step is to install Git on Windows.
I think you can try to get some background of it. So we go to the official site, Git, and it's basically an open source version control system that is really it's great. It's created by the founder of the Linux. So we can directly go to the download link, and once it's downloaded, I already downloaded it to my driver here. So I will directly double click it to install. So you basically accept the default. So click next, and here's also next. So basically everything, you can try to understand it. If not, it's fine. I think it's safe. And click next, and default, next, and in the end you can click install. So after it's done, I think we can move to next step. So yeah, I already installed it. So I was this time I will cancel it. Okay, so after that, so that's the first piece. That's Git.
So our next piece is Python. So we'll use manage the environment called Conda to install that. We will use miniconda. And yeah, here we go. This is the official documentation for miniconda. So miniconda is basically a specialized Python environment that's really good at managing the Python virtual environment. So it's also very small, and it can create a different environment that contains individual Python. For example, you can have one Python like 3.9 for one of them, and then there's 3.10 for another, and they are operating independently. So that's really wonderful, and I highly recommend it. So in here, if you scroll down, you can go to the Windows and 64-bit. This one, you can just click it, it will download it. So as I already have it, so I will just simply double click it to install it, and mostly also accept the default, and, read it and agree, and you can install it for yourself or for all users. It's fine. So I will accept those, and then there's an advanced option. You can you can leave them as this, or you can click install. So it will take probably a few minutes, and then yeah, you are all set. Okay, yeah, here we go. So the next step we want to do is to create a Python environment using the miniconda we just installed. So in order to start the miniconda, we can search in the search box miniconda. Yeah, there's the first item is the anaconda prompt. So all right, so here we go. There's a command called Conda. You can check the help guide. So there's different options you can do. And for this demonstration, I wanted to create a new Conda environment. Yeah, you can see here it does a create. Yeah, I took some notes here. So yeah, as you can see, the command is conda create. You give your environment a name. We can call it SD39 new, and we will need to specify the version of the Python 3.9, and Y is basically say that you type yes for multiple questions. So make sure there's no error, and then you can click the press the enter, so it will kick off the installation. So it will take probably a little while, and then you're done, and then we can activate it. So conda activate SD39 and the new. All right, yeah, you can see the beginning of the line is the name of the environment, SD39 new. Yeah, that's it. So we can list like what package was installed. We can do conda list. So that's not much because it's basically a Python 3.9.15 packages we need. We want to install a package called diffusers. It was created by the Hugging Face. So they really allow you to run multiple deep learning, machine learning models. So we will do that. Diffusers. Okay. Yeah, it will first download and download the dependencies and then install it. So it should be quickly. And then we will install the transformers. Yeah, there's also another famous package for the machine learning and deep learning. And next we install the onnxruntime. Yeah, the first time I like tried to install it, it gave me some error, and then I found out that I did the wrong spelling. So make sure you spell it correct. And so the next one is onnx. Okay, there's another package called Torch. We need to install. Already, so the next thing we will need to do is specialized to the AMD GPU. So for AMD GPU, there's a package called DirectML. So that enables like people to utilize the cores from AMD GPU to run the machine learning models. So we need to go to let's go to the DirectML location, and it's right here. So you can find there's a pre-compiled version for Python that you can install. So in this case, because we have Python 3.9, so we will click the third in the list. So click this one, and it will download to your computer. So yeah, so it will be downloaded to your computer, and then you can install it into your environment. Yeah, make sure you are still in the Conda environment. Yeah, make sure you have the correct path and the correct name, and you can ensure that it is indeed the version you want to install. Yeah, we can see it's CP39. Yeah, click enter, and it will quickly installed. All right, so next is may take a little longer. So next we will utilize a published model by Hugging Face, and we will need to convert it to onnx. So the command you will need is there's already a Python script that you can download. So we quickly search the name it, and you can see the script is right here. So you can read that and see, you try to make a sense of it. So it's basically, it will convert existing model and make it working with onnx. So you can download it, and we will save it to our desktop. Okay. Save it as Python. So we will be able to save it. And after save it, we can utilize it to do the conversion. So this step, it will take a bit long because it will download the actual model files, configuration files. It's probably around 5 GB, so it may take a while, depends on the speed of your internet. So we will try to enter it here. So yeah, so make sure that you have the correct path to the Python. So it's and you can convert to py, and then you enter the model path and the output path. Yeah, so this one will convert the online model into your local directory, and that will be working with our software. So like our output path will be in our C drive. So with our C drive, so and because the current location is your home directory, so you go to user, is my name. So in here I will have a folder called a StableDiffusionOnnx. Yeah, you can create it. So and then you can kick off the process. So because I already have that, so I will create a new one called onnx stable diffusion scripts 1. So and I will press enter, so it will start the process. So this process will take a bit longer, so it needed to download some really large files. environment, you type Python, go to the Python command prompt. So from there you can start the magic. So you there's some command line you want to do, and they are basically some Python script. There's some warning, but don't worry, I think those should be fine. Initially, it may take some time. Already, so next you will define your prompt. So I will define a prompt a photo of a king riding a horse in the Call of Duty game. Yeah, it's basically for testing purpose. So, and then we can do the actual compiling, actual calculation. So before we do it, we will do a quick showcase, just to show like our GPU and the CPU. Okay, so our GPU is here, and once we on the right, you can see that I'm about to kicking off the process. So yeah, so on the left, that's the GPU status. So you can see right here, it's about like over half of it is working compared to the previous near zero. Yeah, and you look at the dedicated GPU memory. Right now, it's the maximum, already maximum 12 gigabytes. And we will also try to look at the GPU Z information. It's here. So we go to the sensor part, and the power draw. Yeah, it's definitely, it's a little slower, but it might be because of my setup. Yeah, you can give it a try and let me know like how yours doing. I'm interested to see different results. And this is just my initial experiment. I'm sure that there's maybe some better way, some advanced ways to do that. And yeah, do please let me know. I'm really appreciating those. I also see that the GPU triple power draw is not very high, so I think that's a good thing. I'm not sure if it is because of the inaccuracy of this software, but normally, if I'm like I was using the NVIDIA GPU, and it seems it took a lot of power. I'm not sure why
here is kind of slow, like kind of low. And we will see like how it goes. And it's also like a majority of the GPU memory has been occupied. So that's kind of maybe a warning sign. Like for example, what if you have only a GPU with 8 gigabytes RAM, right? So that's maybe worth to try. Okay, I think right now it's finished. So as you can see, all the things jumped to almost 0. So also GPU memory also still 12 gigabytes. So let's save our image. We can image.save. So image.save. You can enter the path. So I will save it to the okay. Yeah, I'll just save it to test photo.png. And all right, let's go to our directory, and we can find the test photo. Oh yeah, it looks nice. Yeah, I think this kind of really fun, right? So if you play the Call of Duty game, I think you should remember about the theme. So yeah, I think go ahead, give it a try. I think it's really a wonderful software. I think I'm really glad that they open sourced it, and I can't wait to hear about your results, and let me know if you encounter any questions. I will provide you the exact version of the software packages I used, so you were able to reproduce my results without issue. Yeah, hope you enjoy. Thank you very much. If you enjoy my video, please subscribe to my channel. See you next time. Bye bye.